Right, so we're looking at the big picture of statistics. We're looking at the first section, which is probability, and now we're going to go into the subtopics. And the first subtopic is probability theory. I'm going to jump over. So here it is. I've opened up probability theory here into all its subtopics. I've opened it up all the way to the bottom. Now I'm not going to go in any great detail here. I'm not going to go into any mathematical detail. We're not going to do the maths of all of this. The mathematics of all of this does exist, but I'm not going to go into it. And so what we're going to do is we're going to look at the 5 different parts of probability theory. And this is going to set a framework for everything, absolutely everything that's to come. And I hope you'll see that by the time we've got to the end of this little video that you've got a much better understanding of why we have a probability theory at all. Okay, so as we know, you probably already know this, that probability is the study of uncertainty. Actually, statistics is the study of uncertainty. Mathematics itself is it's all about certainties. You can calculate things mathematically and you get an exact answer. It's only where you start to get uncertainty in your data and in the things that you're calculating that you have to go into statistics. You have to start thinking about things like how likely is it that an event will happen? What are the odds? What's the chance that it's gonna that something is going to happen? Okay, and as we know, I'm sure you've seen this before. When you come into chance, you start talking about combinations and permutations and doing lots of mathematical calculations of these things. I'm not going to go into that because most people think that that's what it's all about. That's what probability is all about. It's about flipping coins and throwing dice, and then you calculate the combinations and the permutations. Actually, that's just one small part of it, and it's actually the part that puts most people off because it's not the most important part. The important part of probability is the framework that it builds for us. So okay, so we know a little about uncertainty already, and for this uncertainty to be able to do something with it, we have to create what we call a probability space, and within this probability space, events happen. Our experiment is going to happen inside, and each event that happens has a probability that you can attach to it. You may or you may not attach a probability to it. It doesn't matter. The fact is that you're going to create a probability space in which to run your experiment. The best way of thinking about a probability space, as far as I'm concerned, is in your mind you create a cardboard box, right? And this cardboard box is going to hold your experiment. And you're going to put everything inside this cardboard box that you are going to study in your experiment. And you're going to put outside the box all the things that you do not want to look at in your experiment. So let me give you a bit of an example of what I mean by this. So you're going to collect data. You're going to do a study on breast cancer. It's something that's very close to my heart. I studied breast cancer for many years, so I know it quite well. Now, what the thing is with breast cancer, if you were to take your patients and say, well, they have different measurements. One of the measurements is their gender. Okay, so you've got males and you've got females. Now, the pathology of the male breast cancer is very different to the female breast cancer. So you might actually want to separate these out. You might want to say, actually, I only want to study female breast cancer, in which case the variable, and we'll talk about what variables are in a few moments, you're going to take your female gender and you're going to put it inside your box. The male gender, you're not going to study that. That's going to confuse the issue. So you take that and you put it outside of your box. I mean, actually do it in your mind. You're going through a variable and you're making a decision. Is this in my box or is it not in my box? And you actually, in your mind, physically place it in your box or outside your box so that you've got a visualization of what is important in terms of your study. And you can do that for every variable that you've got. You should do that for every variable you've got. You're going to collect in your box your study. You're making decisions at this stage. What is going to be in and what is going to be out? What is important? What is not important? And this concept of a probability space is actually really important, because this is where your experiment is going to take place. Okay, it might be a theoretical construct, but it's really important for you to start thinking about this probability space, because it helps you to make decisions about your study before you start collecting data. You then know which data that you're going to collect. And so when you get into this probability space and you're thinking about putting your data in there, you've got two different types of probability that you're going to be dealing with. There's a theoretical probability and an empirical probability. The theoretical probability, let's think of this in terms of flipping a coin. I said I wasn't going to do this, but actually it's the easiest way of explaining it. Okay, a theoretical probability. You've got a coin and you're going to flip this coin. You already know, in theory, that half of the times that you flip it, it's going to be heads, and the other half of the time, it's going to be tails. This is your mathematical reasoning. This is your theoretical probability. And the sample space, your probability space, your cardboard box in your mind, has got to contain all possible outcomes. So in this box, you're going to get the coin, and you're going to put in the box heads, and you're going to put in the box tails. They both have to go in there. All possible outcomes have got to go into that box. Now, I know it's only a theoretical construct, but the idea is that you're making decisions, as I've just said. Okay, so that's the theoretical probability. It's thinking about the experiment that you're going to do and thinking about what the outcomes are going to be, all the possible outcomes, and then they go in your box. The empirical probability is actually doing the experiment. So this is experimental. This is where you actually pick up a coin and you start flipping it, and you get a head, and you get a tail, and you get a head, and you get another head, and you get another head, and then you get a tail. All of these, they go in the box. These are your observed outcomes. And of course, your probability box has got to contain all your observed outcomes. So in your box now, you've got all your possible outcomes and all your observed outcomes. The possible outcomes, when you're talking about flipping a coin, is heads, tails, and there's one more possibility. That 1 in a million chance that the coin lands on its edge and stands up. It's so small, the possibility, that you probably don't even think about it. But that theoretical probability, that goes in your box. Because empirically, experimentally, it might just happen. It probably won't. But you've got to put in your box the idea that it could possibly happen. But empirically, it probably won't. And you'll probably just get heads and you'll get tails. And all those heads and the tails, they go in the box. Right? So you've got a theoretical experiment going on, and you've got an actual experiment going on, and all of those go in your box. So you can start to think about the experiment that you're going to do. Okay, we've also got something which we call the law of large numbers. Now this is really, really important, and what this tells us is that in the long run, if you run a lot of experiments, the empirical probability is going to be the same as the theoretical probability. Okay, let's think about this in terms of our flipping coin experiment. Okay, theoretical probability. You're going to take a coin and you're going to flip it lots of times. How many times is it going to land heads, and how many times is it going to land tails? It's going to be equal. It's going to be exactly the same. It's a 50-50 chance. That's theoretical. Now get a coin and now flip it so many times. How many times? 10. Let's say 10. You flip it 10 times. Is it going to be 5 heads and 5 tails every time? No, absolutely not. Experiment and theory are not the same. You can flip those 10 coins and you can get 7 heads and 3 tails. Or you can get 2 heads and 8 tails. You never know what you're going to get. But what the law of large numbers tells us is that in the long run, if you repeat this experiment enough, if your numbers are large enough, the empirical probability, your actual experiment, is going to be the same as the theoretical probability. It's going to be the same in the long run. Now, in terms of flipping a coin, it doesn't seem that important. Flipping coins is not that important. There are no jobs exist where people just sit around flipping coins. So it's not that important. But in terms of making an experiment, the experiment might be we're trying to cure cancer, for example. This experiment is obviously very, very important, and we want to get it right. Now, if we wanted to do the experiment correctly to cure cancer, what we'd do is we'd go out and we'd gather together everybody in the world that has got cancer, and we'd take all the data that we need from them, and then we'd do all the analysis. We've got all the patients, we've got all the data, we've got everything, and it all works. We'd have an answer. Yeah, but how much is that going to cost? It's just not feasible. We can't do it. So what we do instead is we take a small population. We take a few hundred patients, not millions. And we then take the data that we need, we do our analysis, we get a result, and then we say, and that result, we can extrapolate that into the whole population, into the full population. Well, the law of large numbers tells us that we can do that. In the long run, the empirical probability is going to be the same as the theoretical probability. If that didn't happen, if the law of large numbers was not true, it would not be possible for us to set up a small experiment and then extrapolate the results into the wider population. And if that was the case, then there would be no science, because science is based on the law of large numbers. You do an experiment on a small sample and then we scale it up to apply to the wider population. And if you can't do that, there is no probability, there is no statistics, there is no science. And we cannot make any kind of improvement in our lives. We would still probably be cavemen. In fact, we probably might not exist at all. But anyway, the law of large numbers tells us that we can do something on a small scale and then scale it up to apply to the wider population. And so it's so important. Okay, so I've got to the end of this now, this particular section. So just a little recap about probability theory. I hope you're understanding now how this whole thing it's a framework within which we can operate. We know that we're talking about data in terms of uncertainty. And so to deal with this uncertainty, we have to run an experiment. And we have to decide what we're going to have in our experiment and what we're not going to have. So we get a box and we put into this box all these things that we want to be in, and we decide all the things that's not going to be in the box in our experiment. And then we have a think about this experiment and we decide on what we think the outcome is going to be. This is the theoretical probability. And then we go off and we actually do the experiment, and we start flipping coins or throwing dice or whatever it is that we're doing, and we observe some actual outcomes, and we can put them all into our box to deal with later. Mathematically we can deal with these. And finally, the law of large numbers tells us that as long as our numbers are big enough, and over the long run, this small scale experiment that we've got, we can scale it up to apply to the wider population. So hopefully you've got that this is a really important thing, and I hope that you will, whenever you're doing a study in future, you'll actually construct a box, a probability box in your mind, and you'll do this. You'll put things in, you'll put things out, and it really helps you to get crystal clear in your mind what you're going to be doing in your study, and all your different outcomes, not just your variables, but the possible outcomes of those variables. Okay, so I'm going to stop with this video, and we're going to move on to random variables in the next one.